addition, subtraction, scavenger hunt key. You'll notice I went ahead and labeled A, B, C, D, E, and then you have F, G, H. Okay, and the idea is that we're going to use equations, open number line, and bar diagrams to solve multi-step addition subtraction problems. This is an example, just a layout of a rectangular classroom. You have the problem A, B, C, D, E, F, G, H, laid out in the classroom, posted up, print them up and post them up. And then you can assign the student 1A, student 2B, student 3C, student 4D, student 5E, and you just keep going all the way around until you are done with your students. So they can get up and start there. Once they start there, they got to work out the problems, solve them however they can, model it and what have you. And so when, for example, A, so we'll go look at problem A and come down here. It says Peggy has a rock collection. Her mother gave her 20 new rocks for her birthday. Peggy gave 56 other rocks to her science teacher. She now has 264 rocks. With how many rocks did Peggy start? Okay, so this is what we call a start change results problem, where the start is unknown. These are static problems. These are the more challenging problems because of the beginning and unknown. However, a strategy is going to be very helpful is the use of a number line. And so we're going to go ahead and draw an open number line. And we'll start with the first part here. It says Peggy has a rock collection. And we're going to then denote that somewhere here. Do we know what that rock collection is? No, we do not. Next sentence, her mother gave her 20 new rocks for her birthday. So we're going to go sentence by sentence. So gave, meaning I'm adding on to on the number line. Therefore, if her mother gave her, she needs to go this way. And I know I'm moving 20. Then after that, our next sentence is going to be Peggy gave 56 of the rocks to her science teacher. So now I'm just going sentence by sentence. The next act is going to be then I am going to go back, because now Peggy gave some away, so I've got to go back 56. She now has 264 rocks is the next. She now has 264 rocks. So here, I know I have 264 rocks. The last sentence is with how many rocks did Peggy start? So I am trying to determine this unknown here. A couple of ways to solving this is working backwards. So I know I have 264 and I've got to come back this way. So I'm adding to 264. So I'm going to go ahead and write this here, 264, and I'm adding 56. Then I'm having to go back 20. So now I am going to subtract 20 to get me to my question mark. Okay. Now modeling this using a barred graph is, let's start with Peggy has a rock collection. There's my rock collection. And her mother gave her 20 new rocks. So I know that is 20. Peggy gave 56 of those rocks do, so we're going to denote that as giving away. Therefore, from here, I'm going to go this way, and I'm giving how many? 56. What is the rock collection? Well, first and foremost, Peggy gave 56. She now has 264. So I know this result here is from here, 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 here is 264. So this is a bar using bar diagrams. The green part is my rock collection, and I know Peggy got 20 more here. So as my first sentence is my first part here. My second sentence is this part here. And then my third sentence, Peggy gave 50. This is my third sentence here. And then my fourth sentence of what she now has is this section here. Labeling each part of my model according to what each sentence is very important. With how many rocks did Peggy start? So I'm looking for what this are. Based on my bar diagram, I know a couple of things here. I can say 264 plus 56. 264 plus 56 minus the 20 to get me back to where I'm at over here with the R is going to equal my R. So I can reason with my bar diagram to come up with this equation. And this equation looks a lot like the equation that we decoded over here. So using a number line to reason with, or a bar diagram to reason with, helps us to then write out the expression or the equation that is going to be needed to solve for the unknown. I'm hoping this kind of helps you out. We got to model each one of these. So this is A. And now we'll go ahead and model B now that you have the idea. Hoping that B, you can try and crack this one on your own and see if what that comes out for you.